Okay, so here we're just dealing with like terms, and they say when 3g squared minus 4g plus 2 is subtracted from 7g squared plus 5g minus 1, what's the result, or what's the difference? So that means we have 7g squared plus 5g minus 1, and then we subtract each term here, and I subtract them all separately. It helps me keep track of everything. So minus 3g squared, and then I think I'm subtracting negative 4g, so I'm adding 4g, and then I'm subtracting 2, so minus 2. And now, since I've already kind of applied the subtraction, I think of combining these as adding, because adding a negative is the same thing as subtracting. So that's just easier for me, and I get 4g squared, right, plus 9g minus 3, or plus negative 3. So here that's choice number 3. Next we have the expression, which expression is equivalent to, okay, well they want us to simplify this. Minus 3x times x minus 4 minus 2x times x plus 3. Well, here we're just using the distributive property, and we're going to combine like terms. So minus 3x times x, that's negative 3x squared. Negative 4 times negative 3x is plus 12x. And then we have minus 2x times x, that's negative 2x squared. Minus 2x times 3 is negative 6x. Here, negative 2x squared and negative 3x squared is negative 5x squared. And then we have plus 6x. So here, we can't combine these any further. So that's our final expression. So we're going to factor it out, but we're not going to here. I'm going to pick choice 4. What is the result of 2x squared plus 3xy minus 6 when this is subtracted from x squared minus 7xy plus 2? So we have basically x squared minus 7xy plus 2 minus this other expression. And I want to subtract each expression individually. So minus 2x squared, minus 3xy, and minus negative 6. Well, when you subtract a negative, that's a positive, so we add. And now I just think of adding these two, because we're subtracting and adding negatives is the same as subtracting. So here, right, what happens? Well, when we add these two terms, we get negative x squared, then negative 10xy, and then 8, plus 8. So here, we're going to pick choice 1. Okay, which expression is equivalent to 9x squared minus 16? Well, 9x squared is a perfect square. So that means that the square root of 9x squared equals 3x. And so is 16. The square root of 16 equals 4. So here, when you have the difference of two squares, a squared minus b squared, that always equals a plus b times a minus b. So what that means is, in this case, with 9x squared minus 16, just think of it as the square root of 9x squared, just like we have the square root of a squared as a, as 3x, right, in our parentheses here, and 3x. And then we're subtracting and adding, so adding and subtracting, either order, the square root of the second square, which is 4. And then we're done. So you can quickly identify the structure of the difference of two squares. Notice these two terms are the same, and the second two terms are the same. And notice also the two operations alternate. That's how you know the difference of two squares. So here I'll pick choice 1. Here's the difference of two squares problem. And we know that 9x squared is a perfect square, since the square root of 9x squared is 3x. And of course 100 is a perfect square. The square root of 100 is 10. In general, if you've got two squares and you're subtracting them, we call them the difference, or subtraction of two squares. And then we can just factor it out really quickly. We take the square root of each term. So if it was a squared and b squared, we have ab, and then we just add and subtract. So here we're going to have 3x plus 10 times 3x minus 10. Nice and quick there. Choice 2. This is a difference of two squares problem, because we have the square root of x squared, which is x, and the square root of 36y squared, which is 6y. And with the difference of two squares, a squared minus b squared, we're just going to multiply the square roots, find the square roots of each, and then add them and subtract them. So here we add our square roots, and then put them in parentheses, multiply by the difference of our square roots. And that's choice number 3. Okay, so here they want us to factor out x squared plus x minus 20. And essentially our job is to find two factors of negative 20 that add to positive 1. It's always find the factors of this number that add to this coefficient here. There's no coefficient listed, but it's a 1. So we need two factors of negative 20, right, that add to 1. And those factors are what? Well, they're 5 and negative 4. Since 5 and negative 4, if you multiply them, you get negative 20, and add them and get positive 1, you could pick choice 2. You can see the factors are right there, plus 5 minus 4. Okay, here they want us to factor. We have two perfect squares because 9a squared square root, that's 3a, and 64b squared square root is 8b. So we're subtracting these two squares. It's called the difference of two squares. And the nice formula to work with there is that if you're subtracting two squares, find the square roots, right? Put them in parentheses, and then add one pair of square roots and subtract the other. So here we have 3a plus 8b, right, times 3a minus 8b. This is called a difference of squares problem, and the answer I pick is choice 3. And they can appear in either order because multiplication is commutative, so we can have this parentheses first or this one. It doesn't matter. So here we have a difference of two squares problem. 16x squared is a perfect square, right? Because you take the square root and you get 4x. 25 y squared is also a square root. If you take the square root of that, a perfect square, because if we take the square root of that, we get 5y. When you have the difference of two squares, difference, subtract, when you're subtracting two squares, you can quickly factor by finding the square roots. In this case, if it was a squared minus b squared, you would set up a and b in both parentheses, add one pair and subtract the other, and you're done. So here you can get 4x plus 5y, and then 4x minus 5y. And look for that in either order. So this can come first or this one. So I'll pick choice number 1. Here we're multiplying these two. We have negative 3x squared y times 5x y squared plus xy. So if we distribute this to this term right here, we get negative 15 x to the third y to the third. Right? We just multiply like terms. So negative 3 times 5 is negative 15. X squared times x, add the exponents, it's x to the third. Y times y to the squared, add the exponents, we get y to the third. Of course, the exponents next to here are both 1 and 1. So whenever you don't see an exponent, you can assume it's 1 and 1. To finish this, we have minus 3 times this term, so minus 3. X squared times x is x to the third, and y squared. So here, we can find this in choice number 1, right? Okay, they want us to multiply these two. We have x squared minus 1 over x plus 1 times x plus 3 times 3x minus 3. Sometimes it's really nice to factor before you multiply. That allows you to cancel things out. And that's usually the trick to these kind of problems. I notice this first numerator right here is a difference of two squares. Because the square root of x squared is x, the square root of 1 is 1. So we can factor that to x plus 1, right? We add the two square roots times the difference of the two square roots. And watch how nice this is now. We have x plus 1 times x minus 1 times x plus 3. And don't multiply yet. Try to cancel out if you can. Over x plus 1 times, and then we factor this 3 out in both terms, times 3 times x minus 1. So notice that the x plus 1's cancel out, the x minus 1's cancel out, we have x plus 3 over 3, or choice 4. So always try to cancel out before you distribute. Here they want to know the product of these two terms. We have 4x over x minus 1 times x squared minus 1 over 3x plus 3. The nice trick with these kind of problems is that you want to factor before you multiply. The idea is that your life can be a lot simpler that way. So we have 4x times x squared minus 1. Well, that's the difference of two squares. So the square root of x is x, 1 is 1, and of course the format for difference of two squares is we add the two square roots and then subtract them. Don't even bother distributing yet because we're going to try to cancel out. Here we have x minus 1 times 3x plus 3. Well, x minus 1 times, well, here we'll factor out the 3, times 3x plus 1, like this. So look for like parentheses that cancel out. The x plus 1's cancel out, the x minus 1's cancel out, and what's left over is 4x over 3, choice 1. Here we're trying to find this in simplest form. Well, what we want to try to do is factor things out in our numerator to cancel them out. So if I rewrite this over here, we have 2x squared minus 12x. Factor out the common factor, which is, of course, 2, right? And we have x squared minus 12x. And here, actually, we could factor out more. That might help us simplify to see the connection here. And I made a mistake. It should be minus 6x. You can almost see it now. There's still an x in common, so pull that out. So we have 2x, right, times x minus 6. So this is the expression for the numerator. Notice how x minus 6 and x minus 6 cancel out. And then what remains is just 2x, the simplified form of this fraction. So here they want us to factor this in quadratic. We have 2x squared plus 10x minus 12. Since 2x, 10x, and 12 all have 2 in common, factor it out. It's a good first step. So you have x squared plus 5x minus 6. Now to finish this, leave the 2 on the outside. Factor two sets of parentheses, x and x. The common strategy for most people at this point with these types of problems is find factors of negative 6 that add up to positive 5. So for example, I know that negative 1, that negative 6 times 1 is negative 6, and if I add the 2, I get negative 5. So if I switch that, if I had plus 6 times negative 1, that would multiply a negative 6 but add to 5. So plus 6 and negative 1 are going to help me find the roots later on. But here, we're done. We have this in factored form. That's choice 2. In this problem, we're trying to find the solution to the equation x squared minus 6x equals 0. Well, here we want to factor our x. It's a common factor. So we have x times x minus 6, and that equals 0. And now what this means is that x could equal 0, right? Because we're multiplying x by this number here, and they're telling us that the answer is 0. So the zero product property tells us that if you're multiplying two things and you're getting 0, well then one of them has to be 0, or the other has to be 0, or they both have to be 0. So here we're multiplying these two things and getting 0. So x could be 0, but also x minus 6 could equal 0. Add 6 to both sides, and x could also equal 6. And you could try it. If you plug both of these into the equation here, you will get 0. Right? So the answer is choice 3. Okay. Which value of x makes this expression undefined? Just remember with undefined that you can't divide by 0. So any number divided by 0 is undefined. Well, that means that the denominators, right, cannot equal 0. So you have x squared minus 9 in our numerator, right, over, well here we have, it says x squared plus 7x plus 10. So what x values would make this bottom expression equal 0? So we say x squared plus 7x plus 10 equals 0. But if we look for factors of 10, that add to 7, we can factor this expression out. So we have x and x. Factors of 10 that add to 7 are 5 and 2. So plus 5 plus 2. So what does that mean? Well, here, right, here, if x was equal to negative 5, or if x was equal to negative 2, we would get 0, right? Because if I rewrite this, I get x squared minus 9 over x plus 5, same form, times x plus 2. If x equals negative 5 and plugged it in, this term would be 0, and the whole denominator would be 0. The same is true with negative 2. If we plug that into this term, we would get the whole denominator being 0, and it would be undefined. So our choices are negative 5 and negative 2. But they only give us negative 5, so we'll pick that one. Express this in simplest form. So notice it's 2x squared minus 8x minus 42, don't be overwhelmed here, over 6x squared divided by, so we're going to multiply by the reciprocal. That's going to be our key step here. Right, you're dividing by a fraction, multiply by the reciprocal, times x squared minus 3x over x squared minus 9. I like these problems because they're just structured to cancel out before you have to actually do any crazy multiplication. So on the right-hand side, we have x squared minus 3x that can be factored into x times x minus 3. And the denominator, that's the difference of two squares, so it's x minus 3 times x plus 3. On the left-hand side, factors of negative 42 that add up to negative 8. Well, I know that 7 and 6 go into 42. That's not going to help us. So let's write some factors out for 42. 42 can be broken into 1 times 20, 21. 1 times 41. Sorry. 42 can be broken into 2 times 21. 42 can be broken into 3 times what? Well, times 18. Right? 4 doesn't go into it. 5 doesn't go into it. 6 goes into it 7 times. Does 8 go into it? No. Does 9 go into it? No. Does 10 go into it? No. 11? No. Does 12 go into it? No. So you're starting to see, I think, that here we're not going to be able to find factors of 42, negative 42, that add to negative 8. So what I would do is factor out 2 first. So 2 times x squared minus 4x minus 21. And now we can do it, and we'll do that in a second, 6x squared. So some things are starting to cancel out. The x minus 3's cancel out. Over here we can cross cancel, so x and x squared will become x, and 2 and 6 become 1/3. So that we're almost done now because we have x squared minus 4x minus 21 all over 3 times x plus 3. But fortunately, this numerator can be factored a little bit. Let's see what happens there. Let me just clear this off here. Okay. Well, factors of negative 21 that add to negative 4. Well, I know that negative 7 times positive 3 is negative 21. And if we add them, we do get negative 4. So we can say x times negative 7 and then x times positive 3. Right? This will actually give us that quadratic. But notice the x plus 3's cancel out. And what are we left with? We have x minus 7 over 3x, our simplest form. Okay, so here we have 3x plus 6 over, I'm going to factor this out as I go. Usually with these kind of problems, you're trying to factor and cancel out. So 3x plus 6 has a common factor of 3. 3 times x plus 2 is 3x plus 6 over 4 times x plus 3, because 4 times x is 4x and 4 times 3 is 12. Divided by this next fraction, so we're going to multiply by the reciprocal. X plus 3 over x squared minus 4 is the difference of two squares. So we take the square root of both, that's x and 4, set up our parentheses, and then add and subtract. So now some things will cancel out. This is how these problems are designed. Cross cancel there. Oops, and I made a mistake. This should not be x plus 4, it should be x plus 2. Because we're taking the square root of 4. Alright. X plus 2's cancel out. And you're left with 3 over 4 times x minus 2. Now typically you wouldn't leave this in the denominator, but we can pull up to the numerator by giving it a negative 1. So it's 3 times 4 times x minus 2 to the negative 1 power. And here, right, I think you want to maybe write it like this, if you had to. So put an extra set of brackets around there as well. Okay, when is this function undefined? Well, x over x squared minus 9. X squared minus 9 is the difference of two squares. So that means you take the square root of x, that's x squared, that's x, parentheses, x squared of 9 is 3. So we put plus 3 minus 3. So that's us factoring out x squared minus 9. The reason I'm showing you that is because this function will be undefined when x squared minus 9 equals 0, when the denominator equals 0. So when we put this in a factored form, you can see that there are two numbers that would actually make this denominator equal to 0. If x equals 3 or negative 3, and answer to either one here, we'll get 0. And that would make it undefined because we're dividing by 0. Okay, so here we want to represent this in simplest form. So we want to factor as we go. First it says x squared minus 2x minus 15. What factors of negative 15 add up to negative 2? Well, 15 is prime, right? No, 15 is not prime. I'm sorry, it's late. 5 times 3 is 15, and that's a good starting point, but we need negative values here, so negative 5 times positive 3 is negative 15, and added is negative 2. So that means x plus 5 times x minus 3 is also the same expression. Put this over x squared plus 3x, factor out the x, we get x times x plus 3. This is a common strategy for them in these kinds of tests, right? And also I made a mistake in the numerator, sorry. It should be negative 5 and positive 3. So now x plus 3's cancel out, and what do we get? We get x minus 5 over x. Choice 2. Okay, rectangle problem.